Today's lesson will be focusing on applications of series and sequences. First of all, applications of arithmetic series. So let's just jump straight in to the first question to do with arithmetic series. John starts work on salary of $32,000. His salary will increase by $4,000 per year until it reaches its maximum in the 8th year of his employment. What is his salary in the 8th year? Okay, so we can see that this is going to be our A value, which is the beginning, and this is our D value, which is a common difference. It's going to increase by $4,000 every year. That's cool. So what do we do with it? We're going to find out term 8, right? So Tn, remember, is A plus n minus 1d. N is 8, where it refers to the 8th year. A is going to be $32,000 plus n, which is A, minus 1, times d, which is 4,000. Now this would total to become $60,000. So in the 8th year he should get $60,000 given that increase. Now what will be his total earnings for the 8 years? So total earnings refer to S of n. So remember S of n, there's two formulas for it. The one we're going to use is including the last one because we do have the 8th amount. So S8 is 8 over 2, A, which is 32,000, the first term, plus by the 8th year salary, which in this case is 60,000, right? And putting that in the calculator gives us 368,000. Okay? All right. Question 2. Now, I'm going to start writing on this side, okay? Because I just realized that I should have given more space here. So you can write that side if you have printed it. So, Annabelle is offered two different jobs. Job A has a beginning salary of $48,000 that rises by $3,500 every year until reaching its maximum in the 12th year. Job B has a beginning salary of $42,000 and increases by yearly by a fixed amount to a maximum of $92,600 in the 12th year. In what year will Job B first pay more than Job A? Okay, so what we've got to do is we've got to analyze what we have. So for Job A, we do have the first value and the common difference. So that's A and D. We do have the same thing for the other one. Okay. Oh, actually, no, we don't. We don't have the difference. We do have A here. And we do have T12 being this amount. Okay, for now. So, now, what do we actually do? We have to find out an equation to do with the salary for each job. So I'm going to start off with job A. Okay, I'll write this here. Oops. So job A. All right. Now for job A, Tn is going to be, remember, A plus n minus 1d. So that's $48,000 plus n minus 1 d, which is 3,500. Now I'm going to expand that, and that would give me 48,000 plus 3,500 n minus 3,500, which simplifies to give us 44,500 plus 3,500 n, okay? And that's job A. Now job B will be slightly different. For job B, right, let's start writing the form like this. Oh, sorry, hold on. So for job B, Tn is A plus n minus 1d. A, the starting value of job B, is 42,000 plus n minus 1d. So we don't know what's n. We don't know what's d either. But we're given Tn, or T12, the 12th term, or the 12th salary, as 92,600. So I'll replace that in. So that's for the 12th year. And we'll equate that to 42,000 plus 12 minus 1, which in this case is going to be 11 times d, so it's 11d. Now subtracting that 42,000 over, okay, gives us 50,600 equals 11d. So d is 50,600 over 11, which is 4,600. So that means for job B, right, Tn, if we just rewrite this out, okay, with the d value of 4,600, would be 42,000 plus n minus 1 times 4,600. So expanding that, give us 4,600 n minus 4,600, and then I would get these two values subtracted by each other. So that would be 37,400 plus by 4,600n. Okay, so this is the term form for job B. This is the term form for job A. It's asking when will job B pay more than job A. So you've got to get this equation here and make an inequality where it's greater than this one here. Let's do that. So I'm going to do 37,400 plus 4,600n. Make that greater than 44,500 plus 3,500n. And once I do that, well, moving this n term over and that term over gives us 1,100n greater than 7,100. Dividing both sides by 1,100 will give us n greater than 6.45 ... So what is an n value or number of years that is just greater than 6.45? That would be the 7th year. So in the 7th year, job B will pay more than job A. Moving on. Question B. Which job would have paid the most after 12 years? Okay. So after 12 years, right, we've got to use this formula, which is our sum formula. Now, because we got the A's, N's, and D values down, okay, we can do it for job A. So I'll just say the sum for A. I'll just make it A. Doesn't matter. We'll make that equal to 12 over 2, since that N equals 12. Now, A in this case, for job A, was 48,000, and D was 3,500. So using this formula, it'll be 2 times 48,000 plus n minus 1, which is 12 minus 1, that's 11, times D, which is 3,500. Now that would be equal to 80,700. Oh no, 807,000, sorry. And then for B, we do exactly the same thing. So this is for 12 years. Now for B though, do you have to use that formula? Let me just double check. So because it wants the sum of the whole 12 years worth of income, and it actually gives you the 12th year's income, that's the last term in 12 numbers in a series, you just get that amount plus by that amount, okay, and then times by 12 over 2. And that is because we're using this formula. Right? Okay? So we've got the first term, we've got the last term, which is the 12th term. So we'll get A, which is 42,000. But we're adding that with the 12 years income, which is 92,600. And altogether, that gives us 800 and 7,600. So which job pays more? It will be job B. Pays more. by $600, evidently. Okay? Alright, question 3. Mitchell is stacking logs. He wants to form a stack with 2 in the top row, 3 in the second top row, and so on. Having one more log in each row. If there are 170 logs altogether, how many should Mitchell put in the bottom row? Okay. So this is how it works. There's 2 logs. Okay, I'm going to try and draw it in 3D. There's 2 logs in the top row, then 3 logs in the next row, and then so on. Okay, so there'll be 4 in the next one until there's the last row, which has this many of them. Okay, however many it might have in the bottom row. So there are 170 logs altogether. This represents Sn, as we don't know how many rows there are, I believe. Yep, we don't know. So that's an Sn formula. What else could we know? We know that A, our top of the rows, starts with the number 2. Okay, we have a stack of 2 logs in the top row. So A is 2. But if it's 3 in the second top row, that means the difference between each row and the next row is number 1. So now we're going to use this formula. Sn equals n over 2, 2a, plus n minus 1d, where Sn is going to be 170 equal to n over 2, square bracket, 2a, which is 2 times 2, plus n minus 1d. So n minus 1 would be something we don't know. D is going to be 1. So let's simplify what's inside the square bracket. 2 by 2 is 4, plus n minus 1. Well, that minus 1 and that 4 will simplify to give you 3. So you get 3 plus n. We're going to expand the n with both these terms inside, but the 2 on the other side. So get that 2 times by 170, and that will give us 340. N times 3 is 3n, and n times n is n squared. We're going to move 340 to the other side, so n squared plus 3n minus 340 equals 0. We need 2 factors of 340 that subtract to give you a positive 3. And I'll give you those. If you don't know them, it's okay. You can use quadratic formula. I'm going to let you know now, these are 20 and minus 17. Now, you know that this yields 2 answers. N equals negative 20 and 17. But n is a number of rows, so it can't be negative. So we say, therefore, n has to equal 17, since n has to be a number bigger than 0. So, the question now says, how many should Mitchell put in the bottom row? The bottom row represents the 17th row. And how many belongs to that row represents T17. Tn in this case is A plus n minus 1d. So the 17th row, which is T17, should equal to A, which is the number of logs in the first row, number 2, plus 16, because it's 17 minus 1 in brackets, that's 16, times by d, which is 1. So there'll be 18 logs in the 17th row, and that's how you do it. Okay, I'm going to move on to 4. Polly works on a farm and has to feed the animals. The feed is stored in a shed and must be placed in troughs. So a trough is basically one of these trapezoidal prisons, okay, that horses feed on, or animals feed on. Okay, the first trough, let's just say trough, is 8 meters from the shed, and all the other troughs are 14 meters apart from the in a straight line, as shown in the diagram. How far must Polly walk to the feed all animals if there are 9 troughs altogether, and she must return to the shed to collect more feed after filling each trough. Okay. So, what happens is, a person has to start here to collect the trough. They go here to the first trough and go back. So how much distance has been travelled? 8 plus 8, which is 16. Now, because we're asking, or it's asking you how far must Polly walk to feed other animals, it's asking about the sum of all the distances she travels. So the first distance was 16, obviously. The other one, next one, would be 22 plus another 22, which is 44. And then the next one would be all the way here. So 8 plus 14, that would be 36 times 2. That is going to be 72, plus so on. So this will be total distance to the first trough, second trough, third trough. Now, if there are 9 troughs, that means you need the 9th number, right? Okay, or get the sum of 9 of these numbers. So we're doing S9, basically. Sn, however, is n over 2, bracket 2a, plus n minus 1d. Where a in this case is the number 16. D, however, is the difference between the second and first, or third and second. That is going to be 28. And you can check that by getting 44 plus 28 to give you 72. So now that we do that, S9, sum of 9 terms, will be 9 over 2, bracket 2a, so 2 times 16, plus n minus 1, which is 9 minus 1, times d, which is the number it'll be 28. Putting all this in our calculators does give us S9, the total distance travelled by Polly, to be 1,152 metres. Right, I'm going to move on. Okay, next what we're dealing with is applications of geometric series. So in this case, Cody's parents want him to work for them for 20 days during school holidays. Cody suggests that he be paid 1 cent on the first day, 2 cents on the second day, and 4 cents on the third day, and so on. So you can see that these amounts double. If Cody's parents agree, how much will be paid on the last day? So end of 20 days. So this means that we're finding a term, right? So if the terms as a sequence was 1 cent, then 2 cents, then 4 cents, then so on, okay, where A is going to be 1, D is going to be 2, oh, not D, it'll be R is equal to 2, in this case, sorry. Using the formula, Tn equals to AR to the power n minus 1, we know that the 20th day, okay, which is the last day, whoops, okay, 20th day is the last day, T20, 20th term, would be A, which is 1, times R, which is 2, to the power of n minus 1, which is 20 minus 1. It's 19. So that is 2 to the power 19, which is simply equal to 524,288, but this will be cents, okay? So this is wrong, sorry. So in dollars, this would be 5,242 and 88 cents if you divide this by 100. Question B. What were Cody's average earnings per day to the nearest dollar? Okay. So to get his average earnings, you need to find out the total earnings first of all. So this will be S20. But before we write that, we should write Sn equal to A bracket R to the power of n minus 1 over R minus 1. Now, S20 will be equal to A. A is going to be the first value, which was 2. bracket, R, and, oh, actually, you know what? I did that wrong, sorry. A is number 1. Look in the wrong place. That's the first term. The ratio is 2, so we're doubling each time. Power of 20, 20 terms, minus 1 over 2 minus 1. This gives us a total of 1,048,575 cents. Now, that's the same thing as $10,485.75 if you divide by 100. So the average earnings per day will be that amount divided by the number 20. And that would equal to $524.2875. And to the nearest dollar, that would be $524. All right, moving on to the next question. Question 2. A layer of tinting for a car window lets in 95% of light. So you might see, like, in a car, you can't really see the inside. It's because it's tinted. So if it lets 95% of light in, that means 5% is blocked. So what percentage of light is let in by 2 layers of tinting? So if the first tint only lets in 95%, and this goes through, right? Okay, this goes through here. Then if it goes through another layer of tinting, okay, I should actually write down 95% here because 100% was in first. Okay, now 95% of this light went through, and it's going through another window, so 95% of this value goes through. So this means that we should do 95% of 95%, which is 0.95 times 0.95. That would equal to 0.9025, which is equal to 90.25%. Now, what happens if there's 3 layers of tinting? Then that will mean that this has to times by itself 3 times. So you have 0.95 to the power of 3 instead, which is 0.857. But as a percentage, that would be 85.7% after multiplying by 100. Now in part 3, you know what to do. 10 layers of tinting, same thing, just put it to a power of 10. So that would be 0.95 to the power of 10, which is 0.5987, right? And this keeps going. Just double check that. Yep, keeps going. Now, if I times that by 100, that will give us 59.87, it's 873 %. But you can round it to whatever you want. So I'm just going to say around 59.9%. Now, how many layers will let in 40% of light? Okay. So it seems like the layers is indicated by the power all the time. Okay, if you look at part 3. So if we don't know what this is, we'll just call it n. But we know that the base has to be 0.95 for 95% of light to go through every single time. So we raise this base to the power of n equal to 40%, which is the same thing as 0.4. And you know that we have to use logarithms now to find the value of n. So log both sides and put n at the front, and that's equal to natural logarithm of 0.4. We divide log of 0.95 over, so that n is log of 0.4 over log of 0.95. Now that would equal to 17.9. something, I think. Let me just double check. Yep, oh, that actually is rounded. So that actually gets you 17.86 something on your calculator. But to the nearest whole number, it will be 18. So 18 layers. Okay? All right. So, question 3. A ball is dropped from a height of 1 meter and bounces up to a third of its height. It continues bouncing, rising 1/3 of its height on each bounce until it eventually reaches the ground. What is the total distance through which it travels? Okay. So for this question, I think it's best to draw a diagram. So if a ball is dropped from a height of 1 meter, that means it's like this. That's 1 meter. Then it bounces, right? Rising to a third of its height on each bounce. So if you drop it by 1 meter, it's only going to increase again by a third of the meter. Let's just say that's a third. And then it's going to decrease again and hit the ground. So it's going to travel again a third of a meter. And the next thing is it would it would just rise by a third of its height on each bounce. So if it dropped to the floor by 1/3 of the meter, it's going to rise by a third of this. A third of a third will be a ninth. Okay, and then we drop by 1/9 of a meter again. And this will keep on going again and again and again. So what is the total distance then? D, the total distance, will be 1 plus 1/3 plus 1/3 plus 1/9 plus 1/9 plus a third of this, which is 1/27, plus itself again because it's dropping down, plus a dot, equals. Now, that will be 1 plus 2 lots of a third, because there's 2 of them, then 2 lots of 1/9, and so forth. So you can see that this is going to be a limiting sum because A is 1/3 and R is 1/3. And you know that it's going to keep going up and down and up and down all the time. All right? So we make this equal to 1 plus 2 times, and we use the formula S of infinity equals to A over 1 minus R. 1/3 is going to be A over 1 minus R, which is going to be 1/3 also. And this will be 1 plus the same thing as 2 times 1/3 over 2/3. That will make the 3's cancel out, so you'll get 1 plus 2 times half, which is 1 plus 1, and that's 2 meters. Okay, so eventually by bouncing the ball up and down, this whole distance, if it keeps on going, this whole system will total to be 2 meters. All right, we'll stop there. We'll leave the rest of the work for next period.